Today's lesson is on solving systems by graphing, part 1. A system of linear equations is two or more equations that use the same variables. The solution to a system of linear equations is the ordered pairs that makes all of the equations in the system true. All right, let's look at the first example. Use the graph at the right to graph the following equations. So this is just like yesterday, except we are going to graph two equations, and we are going to look for where they intersect. All right, so look at the first one here. If we plot that, we would start at our y-intercept, which is 3. And then looking at the slope, which is 1/2, because it's positive 1/2, we are going to go up and right. So if you'll go from this point that you have, you're going to go up 1 and right 2. Put a dot there, and then you'll go up 1 and right 2 again, and you'll continue with that pattern. Now, once you get all of your points going to the right, you can also go backwards the other direction just to fill in your graph nicely. So the opposite of going up and to the right would be to go down and to the left. Make sure you take your line all the way through the coordinate plane and add your arrows. All right, the best way to see what's happening with this system of equations, these two equations, is that you have straight lines. So you're going to have to really make sure you use your ruler so that it's clear. All right, looking at the next one that we have here, remember if we don't see a y-intercept, we can always put +0, and we start at the origin. This is called the origin, so we put our dot here. Another reminder from yesterday is that our slope is 2, and so it's helpful to have a fraction so we know how far to rise and run. So we can write that as 2 over 1. So from 0, we're going to go up 2 and right 1. Up 2, right 1. Continue the pattern. Now, we do see where it crosses, so I don't need to go backwards the other way, but sometimes you might need to go the other direction just to see clearly where they intersect. So, do the graphed equations have any points in common? I kind of already gave it away. The answer is yes, it's where they intersect right here. That's the point that they have in common. So, we will write yes, and then what is that ordered pair where they intersect? Remember, you go on the x-axis first when we're plotting points, so it's going to be at +2 and then +4. Now, check. Use the space below to prove that this point is a solution to both equations. Well, even though we feel really confident that we graphed these correctly and we can see where they intersect, it's going to be helpful just in case we graph something wrong for us to check our answer. So we're going to take the two equations that were given to us in the beginning, the y equals 1/2 x plus 3, and the y equals 2x, and we are going to check both of those. So if we think that the solution is 2, 4, remember the first number in the coordinate in the ordered pair is your x coordinate, and the second is the y coordinate. So we need to make sure we plug those in correctly. So if y is 4, I'm going to put 4 here, equals 1/2 times x. X we think is 2, and then we have our plus 3. Now, the 4 is, there's nothing to do on that side of the equal sign. So all we need to do is what's on this other side. So 1/2 times 2, or half of 2, is 1, and then plus 3, 1 plus 3 is 4. And this side was 4, so it checks out. It works for that one, but it has to work for both, so let's go check the other one. So our y value we think is 4. Our x value we think is 2. 2 times 2 is 4, so both sides match up, and so therefore we know that that is the correct solution to the system. Remember, this is the system of equations. It's two or more equations. The solution is the 2, 4. All right, using the problem above, describe in your own words how graphing equations can help you find the solution to a system of equations. So, by graphing your equations, maybe we should say by graphing our equations, we can see the point of intersection. This point is the ordered pair that makes both equations true. All right, graph the equations below to find the solution to the system of equations, then use the check step to prove that the solution works in both equations and show all of your work. All right, so here we go. Let's start with the first one here. What is our y-intercept? If you say +3, that is correct. So we put our dot at +3. Our slope is -1/2, and since it's negative, we are going to go down and right. So from the point that we put on our coordinate plane already, we will go down 1 and right 2, and then we will continue that pattern. Now once we get all of the points going to the right, we can also go backwards. Instead of down and right, we can go up and left, just in case the lines were to cross over here. If our line isn't real straight, it'll be hard to tell. Don't forget to put your arrows on there. All right. The next equation is one of these where we do not have an x and a y. So this is not a diagonal line. It's either horizontal or vertical. Remember, if it's y equals, we go on the y-axis to that number, which is 5, and we just draw a horizontal line through the value of 5. Can you see where they intersect? Right there. What is that ordered pair that we think would be the solution? Remember, starting at the origin, be -4, +5. So my solution is -4, +5. That is the answer, but we have to check it. So we come down here, we write both of our equations that we had. The first one was y equals -1/2 x plus 3, and the other one was just y equals 5. Okay, so checking the first one, again, if we think that this is the correct ordered pair, that's our x and our y. So y we think is 5, so we just plug it in, -1/2. X we think is -4. And you've got your calculator if you need it. Leave the 5 alone. -1/2 times -4. Well, negative times negative is a positive, so 1/2 times 4, or half of 4, would be 2. And we still have the +3. 2 plus 3 is 5, so the sides match up, but it has to work for both equations. So let's go check the other one. Well, we think that y is 5. There's no x here to plug in, so guess what? That works. So this is our solution right here, -4, 5. All right, let's check the next one. If you want to stop and pause it and try this one on your own, this would be a good opportunity for you to do that. All right, the next one, I'm going to start here. My y-intercept is -2, so I'm going to go down to -2 on the y-axis and put a dot. My slope is 1/3, so because it's positive 1/3, I'm going to go up 1 and right 3. And I'm going to continue that pattern. The opposite of going up and to the right would be going down and to the left. and then drawing the line with my arrows. This is my next equation, starting at my y-intercept at positive 2. Now here's my slope. Remember, in front of the x, the coefficient there, that's my slope. So that's a negative 1, and we can always put any integer over 1 to help us out. So since it's negative, we are going to go down 1, right 1. Oh, right there we can see. Continue on. I do not want just dots on your paper. Once you get all of your points on there, you're going to need to connect them and make the line. Hold on just a second. But I can't pause it. I don't, what you don't know. Okay. Real quick then.
This is PSAT stuff. This is reading. Okay. 57th percentile. That's good.
Go on the YouTube channel. You'll hear your knock knock on your 8-2 systems of equations. Okay, sorry, I'm back. Okay, so look at where they intersect right here, and they intersect at 3, -1. All right, so then of course we need to check it. So we write our two equations, y equals 1/3 x minus 2, and y equals -x plus 2. Okay, remember, it's hard for me to see up there, so I'm going to write it down here. I'm trying to check 3, -1. 3 would be my x, and -1 would be my y. That way I can zoom in a little better. Okay, one equation at a time. So underneath the y, I think that y is -1, and then x is 3, so we're going to do 1/3 times 3 minus 2. So 1/3 times 3 would be 1 minus 2, which is -1. So both sides match up. All right, let's try the other side. Y is -1, x is 3. Well, this says -x, so we're going to have to put a -3 plus 2. -3 plus 2 is -1. So it works, so our solution is correct. All right, number 5. Notice that this one has a little something extra, because this one is not in slope-intercept form, so we are going to need to go somewhere to solve this for y. I'm not sure that you have much room. Maybe you could try to fit it in right here, possibly. I'm going to go over here to the side. So we have -6x plus 2y equals -8. Remember from the day before that we take our term with the x, we move it to the other side, but of course we have to change signs. Since it's a -6x there, it's going to become a +6x on the other side. So we still have positive 2y equals, and then it's a positive 6x, and that was a -8. Our last step is to divide by 2 all the way across. 6 divided by 2 is 3, although since that's the slope, we would like it a fraction, so we'll put a 1 under it. So 3/1x, and then minus 8 divided by 2 is 4. So now we can graph. So we start at our y-intercept, which is -4. And then the slope is positive 3/1. So we're going to go up 3/1, up 3/1, up 3/1, up 3/1. We could do the opposite if we need to get another point down here. We could go back to where we started and go down 3 and left 1 in order to get another point. Okay, let's graph this last one here. So we start at +6. I guess it's not the last one, sorry, but +6, and then since it's -2/1, we go down to right 1, down to right 1. There we can see where it's crossing. Keep going though. Down to right 1, down to right 1. I feel like my circles are not good. Draw draw your line. Do not just leave points on there. And now you can see where they intersect right here. So figure out what that ordered pair is. Let's write down that ordered pair as our solution. If you said 2, 2, you would be correct. And now let's check it. So we got to write both of those equations down that we had. So negative 6x plus 2y equals negative 8. And y equals negative 2x plus 6. So we thought it was 2, 2, so the x and the y we think are 2. So I'm going to put a 2 in for both of those. So this would be negative 12 plus 4. This side is still negative 8. Negative 12 plus 4 is negative 8. So we did that. Well, it works for that equation. We know that 2, 2 is a solution for that one. But in order for it to be a solution for the system, it has to work for both. So we're going to plug it in for the x and y over here. So this would be negative 4 plus 6, which is positive 2. So it works. Good. So remember, the answer to your problem, the solution, is this ordered pair right here. That's the solution. Okay, on number 6, if you want to pause this one and try this one on your own, you can. Those of you that are in my room right now, I'm making a video and I don't know how to pause this thing. So I've got 2 more problems and then I will be with y'all. Okay, number 6. So you would have to solve this one for y. So remember, we move this over. So we end up with positive 4y equals positive x minus 4. And then we have to divide by 4 all the way across. So we end up with y equals, now x divided by 4, there's really a 1 in front of it. So it's 1 over 4x. And then 4 divided by 4 is 1, so minus 1. So that's our starting point, negative 1. And then our slope is 1/4, positive. So we go up 1, right 4. Up 1, right 4. What's the opposite of going up and right? Down and left. Down and left. Okay, the next equation, it's already solved for y, so we can just start graphing. It starts at negative 2, and then it goes up 1, right 2. Up 1. That's going to be my line's a little bit bad there, and I think that's going to make it hard. Let me redo my line a little bit. Oh, that's still not real great. Hopefully your lines are better. If your line's not real good, it will make it hard to see where they cross if they're crossing at a close area. Okay, let me start over at negative 2, and then I went up 1, right 2. Yeah, see, the last time it looked like it was actually crossing there, but it's really not. Up 1, right 2, up 1, right 2. No, I really don't need to go the other direction because I can see where they cross. It's kind of hard to do it on here. Hopefully you're using a ruler so that it's nice and neat. You can see they cross there. What ordered pair would that be? 4, 0 is what I'm thinking. So let's try that out. So we come down here, we write our equations. Negative x plus 4y equals negative 4. And y equals 1/2 x minus 2. So we're plugging in 4, 0. This is my x and my y. Okay, so this first one starts out with negative x, so I'm going to plug in 4, so that's negative 4 plus 4 times y, which is 0, equals negative 4. Well, 4 times 0 is just 0, so that's just going to go away. So we're just left with negative 4 equals negative 4, which is correct. Okay, and then we're going to try the other one. So we put in 0 for y, and we have 1/2 times 4 minus 2. 1/2 of 4 is 2 minus 2, which is 0, so that works. So our solution is correct. The solution that we thought, 4, 0 is correct. All right, last one. Parking garage A charges $3 per hour for parking. Parking garage B charges a fee of $2 plus $2 per hour for parking. Write an equation to represent the charges for both garages. Okay, so we're going to write our own equations first. So let's look here. Parking garage A charges $3 per hour for parking. So if the hours is just gonna be our X, and we don't know how many, hours we're gonna have, we could write Y equals $3 per hour, so 3 times X would be good. All right, and then garage B charges $2 plus $2 per hour for parking. So what do you think that equation would look like? $2 plus $2 per hour for parking. So you could put 2 plus 2x, but since we're used to having the x first, I'm going to write 2x plus 2. All right, part B says to graph both of those. Well, we know that with the first one, garage A, we can have a plus 0 if we want, so that we know where to start. All right, and then the slope is 3, which is the same thing as 3 over 1. So from this point, we can go up 3 over 1. Or we can go down 3 and left 1. Draw your line with your arrow. Okay, the next one, we start at positive 2. And then we go up 2, right 1. Up 2, right 1, which you can see it's crossing. My lines are a little off, but you should be able to see that it's crossing right there. Sorry about that. So what ordered pair would that be? That would be at, what is the solution to the system based on the graph? 2, 6. What does the solution mean in the context of the situation? What that would mean is for 2 hours, we should probably write that correctly. For 2 hours, both parking garages would charge $6.